What's up, search nerds?
Hey, Nate. All right, we're going to get started. Thanks for joining, everybody. With us this week, we had Anthony Groves from O'Reilly, and he's going to talk about how to start climbing the relevance mountain and make sure you can keep climbing. I had the pleasure of meeting Anthony a couple times, and I'm really looking forward to this talk. So I'm going to stop my share, and Anthony, take it away.
Awesome. Let me go and share my slide deck here. All right. Yeah, so hello, everyone. My name is Anthony Groves, and today I'm going to be talking to you all about how to effectively begin improving search relevance. And so, as I'm sure a lot of you know, like search and search relevance, it's a huge field, right? Like there's so many technologies, frameworks, buzzwords. You know, we have things like judgment data, NLP, nDCG, CTR, ERR, MRR, LTR, right? And so, you know, a lot of us know what those things are. They're embedded in our relevance engineering practices. But for someone just getting started with search relevance, all of those things can be really daunting. It can be hard to understand what all of it means. You know, it can be especially difficult for someone just getting started with search relevance to understand what approach, what framework, what metric should they be using first when they're just getting started. And so as a lot of us know, like improving search relevance isn't just a one and done deal. You don't just push out one major improvement and call it a day and, you know, come back 5 years later and do that again, right? It's an ongoing effort. You want to be constantly improving the relevancy of your search engine. And so open source connections like to call this climbing the relevance mountain. I love that terminology and I'm reusing it here. So this talk, you know, I'm really going to be talking about how to start climbing that relevance mountain effectively. I'm going to be doing that by sharing O'Reilly Media in our journey on getting started climbing that relevance mountain. And what I want to do is really take a close look at not just how we were effective in starting to climb the relevance mountain, but how we made sure that we can keep climbing that mountain. So a little bit about me. I'm the technical lead of search at O'Reilly Media. I work remotely from Richmond, Virginia. Before O'Reilly Media, I worked on a few different teams at IBM. So I got to work on the IBM Open Platform team, the Watson Discovery team, and then the Watson Health team. And what's cool about this is I got to work with Apache Solr in some way on each of these teams. But it was mostly like a big data or like a NoSQL database sort of way. It wasn't until I joined O'Reilly Media at the end of 2018 where I really got started with search and search relevance. So, you know, I'm much more of a backend engineer. My technical interests are things like search relevance, big data, API design. My hobbies are music, so I'm a huge music nerd, love board games. And as you can see from all the different, you know, IBM offices that I've worked at, like I love to travel. And so before I dig in here, I just want to give an overview of this talk. So first, I'm going to be talking about O'Reilly Media. What company are we? And then, you know, what does our online learning platform have? And talk about the search engine that powers our online learning platform. And give a little bit of a history lesson on that search engine and the search team that works on it. And then I'm going to be talking about how we started to break into search relevance engineering, you know, how we started to climb that relevance mountain. So really talking about how we use some fundamental relevance techniques to improve search as quickly and as effectively as possible. And then lastly, I'm going to be talking about this idea of investing in lasting relevance practices, right? Like what we did was we, you know, got relevance improvements out as quickly and effectively as possible. And we made our internal stakeholders really happy with those improvements. And so, you know, making your internal stakeholders happy garners more buy-in. And so taking that buy-in and then using it to develop use a lot more time and effort to develop better relevance engineering tooling and practices so that we can continue climbing that mountain and continue improving search relevance. And so a little bit about my company. You know, if you didn't recognize O'Reilly Media by its name, I'm sure a lot of you now are recognizing what company I'm referring to, seeing all these books here. So yeah, you know, we're the company that publishes those cool programming books with the animals on the cover. So really well known in the technology and especially the programming space. You know, we have a line of conferences that are well known too, like the Strata Data and the AI and the OSCON conferences. All these conferences are virtual now, which is really cool. And we're well known for the books, our conferences, and also really well known for our online learning platform. So, we have these conferences and these books and all of these different content types and features offered on this really nice online learning platform where users can go and, learn a new programming language or build or level up on their existing skills, really focusing on that business and technology space. So this used to be called Safari Books Online. So, that's the predecessor of this on learning platform. So if you've ever used Safari Books Online, like this is basically the evolution of that online learning platform. And so that platform and the search engine that powers it is what I'm going to be talking about today. So, as I mentioned before, this online learning platform has a ton of different features and content types that help users learn a new programming language or level up in their existing skill set and technology. And so you can imagine all these awesome content types and features are only as good as they are discoverable, right? Like O'Reilly Media publishes really great books on programming, and we offer them on our learning platform. But that doesn't mean much if users can't use our search engine to actually find those really good books, right? And so, our search engine it's a Django microservice that's built on top of a Apache Solr cluster. And you can see here, we offer about, 61,000 search results. That's really because we're grouping results together in a certain way. Really, our Solr cluster is indexing and searching over 2.7 million documents. So, 2.7 million different types of results we could potentially return to the user. And so on the left here, I'm showing just a screenshot, a small snippet of our search page, what a result looks like, the different filters that we offer. On the right, I'm really showcasing the different content types that's on our learning platform and in our search engine. We have things like books, videos, learning paths, which are, like a collection of book chapters and video clips that guide the user on a journey towards building a specific skill. We have interactive content like Jupyter Notebooks and Katacoda scenarios. And then we have things like live online trainings where users can register and attend an online class from an expert in their domain. And so you can imagine, like, a lot of these things are really cool. And, there's a lot of good content out there that is really helpful with users, leveling up their skill set. But as I keep saying, like, this content, these features are only as good as they are discoverable. And so you can imagine how important it is to have a robust search engine that, brings back these really great content whenever users are searching for them. So I want to take a look at our user personas, our popular search queries, and also talk about this nice little level of enrichment that we have in our search results. So our search results are all tagged with a topic. We have like a machine learning service that tags all of our results with, what programming language is it or what topic area is it. So on the left here, I'm showing, these are all books that are either have the search topic or one of its subtopics like Solr or Elasticsearch. So you might recognize some of these books. There's, like Solr in Action, Relevant Search. It really adds a nice level of enrichment. And what's useful, what's important about that is that our most popular queries are these topic queries. So on the right here, I'm showing, just some query logs listing our most popular queries on the platform. And you can see here, 30 most popular queries are all technical topic queries, things like Python, Java, JavaScript, Kubernetes. And so this is, what is by far the most popular. Our users are searching for a specific programming language or topic area. And then talking about some of our other popular some of our other popular query groups, we have title queries, so looking for a specific title, and author queries, so looking for content by a specific person, and also some mixed keyword queries. So this idea of only supplying a few words from the title and maybe the author's last name. So these are by far our most popular types of query groups, and topic queries especially dominate the space. And so throughout this talk, I'm going to be talking a lot about the old relevance algorithm versus the new relevance algorithm, and really talking about how we got started with search relevance. But as a lot of you may know, like O'Reilly Media has been around for a very long time. It's a pretty established company. And if you're familiar with Safari Books Online, like that's been a website for a very long time. And so this learning platform isn't new. It's been around for a while. The search engine has been around for a while as well. And so really just giving a quick history lesson on the search engine and search team. Back in the Safari Books Online days, we had people thinking about relevance engineering and building this robust search engine and relevance algorithm. But unfortunately, like you can imagine, like those people would leave and the search team saw multiple iteration of folks. And so the actual search relevance algorithm, before my team started tackling it, wasn't changed since like the end of 2014. That was the last time that O'Reilly Media's search engine really saw people like trying to improve the relevance. And so you can imagine in that time frame between the end of 2014 and like, the beginning, the middle of 2019, the relevance algorithm wasn't changing at all, but yet we were adding a lot more content, a lot more results to the search engine. And so relevance was just degrading as time went on. And it really became like well known in the company as just like being pretty bad for especially for a lot of different queries. Like it just returned really irrelevant results. And as I mentioned before, like this is really important and a really serious issue because our online learning platform is awesome. Like we have so many good books and videos that help people learn programming languages and level up on their skills. But that content is only as good as it is discoverable. And our search engine and its relevance algorithm was not presenting that awesome content to our users. And so it was about a year ago where our search team now, which is comprised of pretty new to the team and the company, everyone joined about a year and a half ago or sooner. And we got together and we said, okay, we know the search engine's bad, the relevance algorithm hasn't been touched in years. How do we go about improving it? So that's what this talk I'm going to be talking about is, how do we start breaking into search relevance and improving it and getting started climbing that relevance mountain. And so I wanted to show just some use cases, some examples of just how bad that old relevance algorithm was. What did it look like before we started improving it? So here's an example query, JavaScript. Right? Very popular programming language. It aligns with I think it was like number 4 in our most popular query list. It aligns with our most popular query type, which is topic queries. You can see here whenever someone would type in JavaScript, the very first book search result that we would give them is a book called Server-Side Development with Node.js and Koa.js, Quick Start Guide. Now, I'm not much of a front-end guy, but I don't even know what Koa.js is. And you can imagine, like, when a user types in JavaScript, what they're hoping to see is good content, great books and videos on learning JavaScript, just generally, learning what JavaScript is and how to program in it. And instead, what we would give them are these books that are, a very narrow niche framework or topic area within JavaScript. It's very far from what the users are expecting and definitely not the ideal experience that we want to present to them. So, looking at this, if I was new to the platform and I had just issued the search query, I would assume that the online learning platform doesn't have like good, well-known books on JavaScript, on, learning JavaScript, which is a shame because O'Reilly Media alone publishes a lot of books on that topic. So another example of the old relevance algorithm, user searches Robert Martin, an author query. A lot of people know Robert Martin, also known as Uncle Bob. He wrote the book Clean Code, has a lot of videos on clean code, clean coder, clean agile, super well known in the programming and software engineering space. But yet, whenever a user comes to our online learning platform and they would type in Robert Martin, these are the results that they would see. The very first result here is a video clip from our Velocity conference. And it's a talk given by the two people named Robert Haynes and Martin Duke. And you can see like how this came back in the search results, right? It's matching on the strings Robert and Martin, right? But it is not matching what the user is expecting to see. This is a classic issue in search and also points to a really good quote that I just love. And it is, match things, not strings. Right, so our search engine did a pretty decent job at matching strings, right? It's matching the word Robert, it's matching the word Martin, right? But it's not matching the thing that users expect to see. The users are clearly thinking about Uncle Bob, Robert Martin, super well known in programming. But what they're getting instead is a talk from Robert Haynes and Martin Duke. And so even looking at like the second result and third result, they're at least talking about Robert Martin. They're referencing Robert Martin, the person. But they're still not the clean code book or the clean code or video series that everyone knows and loves. Like these are really popular content. And so once again, if I was new to this learning platform and I issued this query and saw these results, I would naturally assume that the learning platform just didn't have clean code or didn't have clean agile, which is a shame because it's great content. We want to be giving that great content to our users. So I'm only showing screenshots in these examples here, but I can assure you that the rest of the page is very similar. You know, clean code didn't show up on the first or second page. And so you can imagine it's a pretty serious issue when you talk about having all this great content, but you know, it's not discoverable. And then last but not least, I wanted to give these two very quick examples here. You know, the book Relevant Search by Doug Turnbull and John Berryman, it's their most popular book on the platform on search. And so naturally, when someone issues the query relevant search, which is, you know, essentially the title, or if someone issues a query search Turnbull, you know, which is an example of a mixed keyword query, right? They're searching for search content from Doug Turnbull, right? We're not giving relevant search back as the first result. And that's not a huge deal. Like at least the user can see relevant search if they scroll down a little bit, or you know, they see it on the first page. But it presents this issue that, you know, this is really relevant, really popular content, and you would expect to see that really popular, well-known content first in the result list. And so just want to take a quick look at, you know, what our Solr index looked like, what kind of fields were we indexing and querying over, and what did our old relevance algorithm look like. So on left here, you can see the fields in our Solr. You know, we would index things like title, author, publisher, content type. We have fields that are used to like look up a certain document, like ID fields or URL fields. Two fields I want to call out is, you know, we have a field that is called topic UUIDs, which is used to filter results by topics. So, you know, give me all the results that have the topic Python. And then we also have a popularity field, you know, indicating how much do people use, how much do users use that specific search result? You know, how many users does it get? How often is it used? But we use that popularity field just to enable sorting the results by popularity. And so on the right here, I'm showing all the fields that we were querying with term matching and phrase matching. And they're, you know, some basic fields you would expect: title, chapter title, author, publisher, the actual content. But you can see here, we're not searching the actual topic names at all, right? Despite the fact that topic queries were our most popular kinds of search queries. And we know, like, we're indexing data on what topic that result is. But we were only doing that to be able to filter and not actually search on those topic names. And, you know, we had a nice little recency boost on our results. So, you know, trying to boost more recent content, but we weren't boosting results by popularity at all. And so you can imagine, like, we would have clean code in our search results, and we have a popularity field saying that, hey, this is a really popular piece of content. But whenever someone types in Robert Martin or clean code, we weren't boosting that clean code book by its popularity field. And so I'm sure most of you, after I talk about our common user personas and our popular search queries, and then I show you, you know, what our index used to look like and our relevance algorithm used to look like, I'm sure most of you can already piece together what the major relevance gaps were, right? We had topics, but we weren't searching the actual topic names. We weren't boosting by popularity. You know, some things like our author queries were weak. So we would match on, you know, someone named Robert Haynes and someone named Martin Duke instead of matching on Robert Martin, right? And then our mixed keyword queries were weak too. You know, search Turnbull was not strong. And that's really because our index wasn't built to, you know, handle those kind of mixed keyword queries. And so what we did about a year ago, the search team, was, you know, we got together, we started, after we, you know, read relevant search and watched a lot of Haystack videos, we started to identify these major relevance gaps. And so we got together and we said, okay, you know, we all know that our search engine sucks. You know, it's a pretty well-known thing in the company. We know that it's bad. We want to improve it. We have ideas on how to improve it, but how do we actually get started? You know, what do we do? And so really the biggest idea, like what I think is the most foundational, fundamental technique in search relevance is this idea of signal modeling. You know, I picked this up from the book Relevant Search, and I really think that this is the most important idea when you're getting started with improving search relevance. Signal modeling is this idea of modeling your schema fields and how those fields are queried to best represent your users and the signals that matter to them most, right? I said this quote, match things, not strings. And that's really what this is driving towards. So for the longest time, O'Reilly Media's search engine was treated like a database. It enabled filtering and sorting and looking up data given an ID, right? But it wasn't being built to match our user experiences and our user personas and what our users are expecting in their mental model. And so that's ultimately where these huge relevance gaps came from. And ultimately where we wanted to get started first, patching up our relevance algorithm and our Solr index to more closely match what our users are thinking and expecting whenever they issue queries like Robert Martin. And so I see this as a constant process, right? Like you have to understand your users and your user personas and your different types of search queries to be able to do this signal modeling. And usually, that process of understanding your users is a constant process. Like you're always learning more about your users. There may be, trending behaviors or search queries that pop up. And so this idea of modeling your index and your relevance algorithm based on those users is a constant process. Like you want to be constantly updating this depending on, the more information you find out about your users. And so, like I said, this idea of signal modeling is what I think the most fundamental, foundational step in improving search relevance. Like if you're just getting started improving search relevance, you want to take a look at your index and your relevance algorithm and see if it matches what information you have on your users and what they expect. And so I pulled this quote from the book Relevant Search. It's a great quote that summarizes this well. Users don't care about how your database stores data. They need data represented in a form that lends itself to searching, right? So for the longest time, we were just indexing fields and indexing data just as they were stored in our data sources. We weren't creating fields specifically to improve relevance, specifically to match what our users were thinking. So circling back around, so some of those huge gaps that we identified and just, applying signal modeling to, patch up those gaps. We obviously indexed the topic names and started querying over them. We obviously started adding a popularity boost to relevance algorithms. So super relevant, super popular content was being pushed up higher in the result set. We improved author queries with, boosting phrase matching. And circling back to that idea of mixed keyword queries, a title author mixed keyword, giving a few words from the title and maybe the author's last name. That was a pretty popular, type of query group. And so we didn't have, we had a title field and we had an author field. And we were searching both separately, right? But we added this new field called title author. And this was the first time that we ever added a field to our index that was added strictly to just improve relevance, to match what our users are thinking about. And it wasn't a field that was already in the data source that we were just pulling it from. So, we added this field title author, just a derived field combining both title and author. Well, that let us improve phrase matching on title author queries a lot more. And so, we sat down, we got together and said, okay, what are our gaps? And then we use signal modeling to identify how we can improve those gaps effectively and quickly. So then we said, okay, how do we test this, right? Like it'd be very easy to improve relevance for a specific search query, but you might do that and then you actually break or degrade relevance for a different type of query, right? And so relevance testing is really important. And so we broke this down into 3 different areas. We identified query groups. Then we had offline testing, and then we would ship out our changes to production and had online metrics to measure how users actually took to those changes. And so for query groups, what we did was we realized that it was impossible to test all of our search queries in existence, right? There's too many out there. We don't have the tooling to test even like 200 queries. That's just too much for us, right? And so what we did was we looked at our query logs and we broke out our different queries into different buckets or groups. Things like topic queries, title queries, author queries, mixed keyword queries, that kind of thing. And then what that lets us do is just whenever we're doing testing, we would just test a handful of queries from each group. So it's like this idea that we're trying to improve, let's say like title queries, right? So we would test title queries, make sure that they improve as we would expect, but then also be able to make sure that, we didn't degrade relevance for our author queries or our topic queries. And so, offline metrics, we had a test environment that looked just like our production search page, had production data, really let us to easily manually test relevance in an offline manner. And then we create a judgment list on all of that, which I'll get to in a second. And then we had online metrics like click-through rate and mean reciprocal rank as trailing metrics to really just see, how do these improvements perform out in production. And so I see, both offline and online being really important. Like I think it was really good for us to build confidence, use offline testing to build confidence before we ship the changes, then also verify those changes, worked well out in production. And so talking about our offline metrics, our offline testing here, this is a Google Sheet. And what you're seeing here is this is where we would enter in judgment data and do offline testing. So when I talk about judgment data, what I'm really referring to is, given a search query, how relevant are its results, based on that query, right? And what you can do is once you have that data, once you have those relevance scores for those results in that query, you can start to compute a lot of different relevance metrics for that specific query. And so this is where we get into the nitty gritty of like different metrics and stuff. But what we did was, we didn't build a new, judgment data tool. We didn't even have the time to, get something up and running like Cupid or, some other kind of well-known community tool to do this. We were trying to get out relevance improvements as quickly as possible, right? And so what we did was we just built this Google Sheet here that calculated metrics like DCG, nDCG, average precision for you automatically when you would enter in the judgment data. So that was super quick, super easy to do. And then what we would do is just, duplicate this Google Sheet, issue a query off on our test environment page, and then actually manually, score, like enter in the relevant scores for the results that we would get. And so, and then we'd have these, Google Sheets and these metrics lined up, and we would try to look at, how these metrics change over time. So, we push out an improvement to our, topic queries, which is great. We would enter in this judgment data and, make sure our topic queries improved while also making sure our title queries didn't degrade search relevance performance, that kind of thing. But the pain point here is that we would have to do that every time we would push out an improvement, right? Like each time we improve something, and we wanted to test it in an offline way, we would have to go in and actually manually enter in this relevance scoring, because it's not storing in a database anywhere, this relationship between a query and a result and its relevance, right? And so this worked out really well for us because we only pushed out a handful of improvements, right? Like we identified some huge gaps and improvements that would make drastic changes to our search engine. And this is far from an ideal relevance engineering practice, but this got the job done really quickly for us. And so, what that lets us do is build confidence in our changes before we actually ship them out to production. So, once we are able to ship them out to production, we had some trailing metrics to see, how did that perform out in the wild with our actual users. And so what we used here was click-through rate and mean reciprocal rank. Click-through rate being, for all of our queries, what is the percentage of those queries that resulted in at least one click on a search result? So for example, here, I'm showing like that query Python. And if you look to the right here, Python's click-through rate is 61%. So that's saying for 61% of the search sessions where the query was Python, there was a result click. A user clicked on at least one result. So this is nice. This is far from what is ideal search success metric, but this got the job done for us. This is a very widely known and used search success metric. And it lets us understand, did we make users click on more results? Did users find more results that were at least somewhat interesting to them? And so this was used as our overall success metric for online testing. We also use mean reciprocal rank for the trailing metric, but we didn't use it strictly for a success metric. So mean reciprocal rank is this idea of, where are users clicking, right? Like we know users are clicking from the click-through rate. Now, where are they clicking? Do they have to travel to the 5th or 6th page to actually find something that interests them, right? And so mean reciprocal rank is nice because it says that, the 30th result and the 31st result, the difference between those two is much lower than the difference between the first result in the second result, right? It's really important for our clicks to, for a lot of our queries at least, for our clicks to be, closer to the top of the first page. And we don't want to force users to go off to the second or third page to click. And so, we were really looking at that mean reciprocal rank and just trying to get a better understanding of how does that change with our relevance changes. Now, I mentioned that, mean reciprocal rank, a lot of times it's not even used in this use case. A lot of times it's useful for a binary relevance where there's, there's a query where there's only really just one correct answer to that query, right? Like maybe like a title query, and there's one very glaringly obvious result that is the answer, right? And so we didn't use it in that use case. We really just use it as a metric to understand where users are clicking. And it's hard to enforce mean reciprocal rank in this way as a success metric, because you can imagine a lot of our popular queries are broad queries. And broad queries a lot of times can come with browsing behavior. So a user might search Python, but maybe they just want to see what our online learning platform has for Python. So they might go to page 2 and page 3 and click around. And so we weren't holding ourselves strictly to that mean reciprocal rank, really just using it as an indicator to give us more insights. And so, we did all these tests, we pushed out a lot of improvements to our relevance algorithm. So now I want to show, what does our search look like now, after we did all these improvements. So here's, circling back to that example, JavaScript, user issues the query JavaScript. And now right away, first result is the book, JavaScript, the Definitive Guide, 7th edition. And this is a super well-known, very popular book in JavaScript by O'Reilly Media. It's super helpful. And it's getting to that idea of, helping the user learn JavaScript, right? It's not talking about a specific framework or narrow niche in JavaScript. It is about JavaScript, the language, and it's a very popular book about JavaScript. And then circling back to Robert Martin, user issues the query Robert Martin. Now what they get is the first page is everything by Robert Martin. So we're showing live online trainings where you can go and register and attend a virtual class with Robert Martin himself. We have that clean code book and video that I've been talking about that everyone knows and loves. We're showing that directly on the first page. And users are no longer getting that weird velocity video where it's people named Robert Martin Robert Haynes and Martin Duke. We're showing content by Robert Martin. And really, these are great improvements, but they're really they're initial, right? They're very small. It's really easy for us to use signal modeling to identify improvements that we could make and do that quickly. We had a lot of pressure, so many years the search engine wasn't changed. And so there was a lot of pressure from internal stakeholders to improve it quickly, right? We didn't have this luxury of spending 6 months or 12 months building like relevance tooling and search relevance engineering techniques. Like we had to get these out as quick as possible. And so, we started the search relevance climb. We started climbing that relevance mountain, but we did so in a way to make sure that we can continue climbing that mountain. And so the last thing I want to talk about is just that, establishing a lasting relevance process. So we shipped quick improvements as quickly and effectively as possible. We measured success of those improvements. Entering judgment data in a Google Sheet is far from ideal, as I'm sure a lot of you recognize, but it got the job done, right? And so, we had these huge successes with, pushing out those improvements, which then let us get more buy-in from our internal stakeholders. So many people were impressed and happy with those improvements. Our CEO was, she personally congratulated us and was thrilled with these improvements. And so, having that buy-in from our internal stakeholders then let us go off and spend months, developing actual relevance tools and, a relevance engineering lifecycle so that we didn't have to, keep entering judgment data into a Google Sheet, right? And so this is really like a constant process. It's a cycle. Like, once we're at the phase now where we're just tying off on all that work to, build relevance tooling and, establish like a relevance engineering lifecycle. So now we can start pushing out improvements and tackling, the more difficult search challenges. And that will become easier because we have the tools in place, right? And then once we do that, we'll get more stakeholder buy-in because people will be happy with those improvements. Then we'll get to spend even more time building tools, right? So it's just a constant process. And you need this because improving relevance is an ongoing effort, right? You got to keep climbing that relevance mountain. So, what O'Reilly Media saw was relevance was probably pretty decent back in 2014. but the company just stopped improving it, right? It stopped working on the search engine, search relevance. And so over time, it just, really degraded and got to that point where you would type in Robert Martin and you just couldn't find anything about Robert Martin. And so really making sure that we don't get back to that point, right? Making sure that we keep issuing, improvements to relevance and keep climbing that relevance mountain. And so I want to talk about that last phase. What are some of the things we're doing to improve our tooling and establish a lasting relevance process? So we're adding relevance tools directly to our search page, which I'll actually talk about more on the next slide. We're adding a lot more like relevance testing to make it easier to visualize how our search engine performs over time, and also make it easier for relevance developers to make changes on their local machine and make sure that those relevance changes improve relevance and also doesn't break relevance for other query groups. Then we're also spending some time developing our online metrics more. So I hinted to this before, but click-through rate is only so good, right? It gives you insights into how often users are clicking on search results, but that's only like the first half of the funnel, right? Like you really want to know if the users are benefiting from their search results. So on an e-commerce site like Amazon, you can imagine, yeah, it's cool if you were tracking if users are clicking on the search results, but if they're not purchasing that item, those clicks only mean so much. They're not really the true success metric, right? They're only the first half of that funnel. And the same way it goes on the O'Reilly Media platform, right? Like we have all this great books and videos and live online trainings, but the users are clicking on search results but not registering for that training or not reading the book, then those clicks are only just a little meaningful. They're not really getting towards that end goal and success metric. And so we're spending a lot more time developing that funnel, looking at not just clicks, but the clicks that then lead to the content usage, and how much usage is search actually generating, and trying to use that to use as our online metrics for testing. And so I skipped over this, but just want to share a screenshot of just a glimpse of like our relevance tooling. And so we spent some time identifying some pain points in our first initial relevance engineering tool, aka Google Sheets, and then how we can improve it. And so here is a design example of this. Here is it's our production search page, as you can see, but there's a little toggle at the top here that only for internal folks, behind a launch darkly flag, they can go ahead and turn on this relevance view of the search page. And what that does is show them a lot of different tools that makes tweaking relevance and adding judgment data on relevance a lot easier. So left here, there's like a number picker system where users can use this to record judgment data. So, given a query, how relevant is this result? That can be done now on the actual search page instead of going off and recording that information on a Google Sheet. And what's nice about this is this lets us really build a huge database, a huge volume of judgment data that we can use for a long time, right? Like we no longer have to go in a Google Sheet and enter in judgment data every time we want to push out an improvement. Instead, what we can do is we can just kick off our production relevance tests using this judgment data that we already have stored. And I also, I glossed over this before, but we have the luxury at O'Reilly Media of kind of being subject matter experts on our domain, right? Like our corpus is mostly programming, technical topics and results. And our queries are, topic queries, queries of like Java, Python, all things that, for the most part, we may not be experts in Java, but we at least know what like a good Java result looks like, right? And so we have that luxury, it's not like we have like we're not like a search engine for like a medical corpus, where it's a bunch of medical terms that we don't understand. We have that luxury of being able to record judgment data in our team. And even, now that this is on the search page and it's a lot easier, we can open it up to other people in the company to help us, build this huge volume of judgment data. And so the other, we have other relevance tooling on the search page as well. So at the top here, you can see like this title, topic name boxes. This will let users really just, change our boost value. So if you want to increase the boost value on, matching on our topic name field, you can just change the value here directly and then issue a new search query and then see how that performs. And, similarly on the right here, if you want to understand like, why is this result coming back? What field is it matching on? How strong was that match? What other signals like popularity, recency is playing a part in that matching? You can see that here. And this is really building off of, that Solar Explain feature. And what's nice about all this, there's a lot of tools out there, Cupid especially, like this is very similar to Cupid, but there's a lot of tools out there that do this kind of thing. What's nice about this is, embedding this in our actual search page lets us really easily open it up to other people in the company. So, the search engine we're trying to demystify for other people in the company and let, people understand, why results are coming back the way they are, and really opening up and letting them capture judgment data or look at, why results are coming back. And so really, getting more buy-in from other people in the company and getting more people to understand what relevance engineering looks like. And so you can imagine now that we have these kind of tooling, now we can go off and, start improving relevance more, start tackling more challenges. And really all this is just, a cycle for making sure that not only that we can push out relevance improvements, not only that we start climbing the mountain, but make sure that we can effectively continue climbing that relevance mountain. So that is it. Are there any questions?
Thanks, Anthony. That was awesome. Folks, feel free to drop questions into the chat. You can ask questions on the relevant Slack, or you can just unmute yourself and ask. I think we've got about 40 people-ish in the meeting, so I think we can handle the microphones. All right, so we got a question from Michael Upshaw. How can you measure usage rather than click-through? What are the relevant metrics for an e-learning site?
Yeah, that's a great question. So, first off, I'll start by saying usage looks a little different for different content types, right? So usage of a book is different than usage of a live online training, right? Fortunately, we have a data science team that's spent a lot of time dedicated to developing this idea of what usage is and kind of normalizing it across our different content types. So, they've done a lot of work normalizing what usage looks like across books and videos. So, we track things like how long is the user on our book reader, how many pages do they read, how much do they scroll and interact with that book reader. Also, how long do they watch that video, and then talking about like live online trainings, do they actually register for that live online training, but then actually attend the live online training. And at that point, it's similar to a video where, it's just a session that they're watching this training video. And so it's nice, like we have a data science team that thinks about this and like normalizes that across our content types. But as you can imagine, the more content types you add, so like, interactive types like Jupyter Notebooks and Katacoda scenarios, the more content types we add, the more difficult this becomes. And it's really important to kind of normalize the usage across these types, but also a pretty serious challenge.
Cool. Question from Charlie Hall. How do you agree amongst your raters what level 1 and level 4 is on judgments?
Yeah, that's a great question. So, at our initial judgment list in our Google Sheets it was just our actual relevance engineers recording that data. So we didn't have to worry about that as much. Essentially, we had a meeting and we had like a little guide that kind of talks about, for different types of queries, what does, the most relevant, what does a 4 versus what does a 0 look like? But as we start to open that up to other people internally, other folks outside of our search team, that becomes increasingly important. And that's actually the stage that we're at now. We're developing guides that help people understand, what does a 4 look like versus a 0. And so we have, in terms of actual like validation and verifying our judgment data on the backend side, we added a simple average kappa calculation metric. It's very simple, very basic, just to give us a better understanding of how much do these judgment data, how much do these data ratings differ amongst our users. So you can imagine if we open this up to other internal folks and we have 5 different people rating the same query result pair, we can look at that average kappa value for that query and understand, do those scores match up pretty well or are they pretty different? And at that point, we don't have anything in place to act on that automatically. But so what we could do is, act on that manually. If we see the average kappa value being way off the charts, we can go in and take a look at, maybe that person didn't understand our rubric, or, maybe it was a mistake, and, take actions accordingly.
Yeah, that's awesome. Personally, I advocate for using things like kappa statistics or alpha statistics to understand how raters agree. So I'm really glad to hear you guys are using that. It's not many people do, as far as I know. But those who are interested in understanding that more, definitely check out Fleiss Kappa or Krippendorf's Alpha are two metrics to check out there. Next question is from Maya. How many judgments did you need to get started?
Yeah, that's a great question. I kind of glossed over that. When we were building those Google Sheet judgment data lists, what we were really doing is just recording judgment data for the first 30 results. And so when we talk about how many queries we would judge, a handful of queries, maybe like 5 queries, 10 queries from each topic, or sorry, from each query group. And so at the time we had about like 5, 6 query groups that we identified. And so, that was looking at, anywhere from like 30 to 40 different queries that we would be testing, and 30 results for each query. So that wasn't very large scale, and that was because at the time we had to do that every time we wanted to test a new improvement. Now we're at the point where we're just tying off on that judgment data tooling, and we can start. We'll have a ton of judgment data for 200, 300 queries, and then we can just kick off tests and test a much larger scale of queries.
Awesome. I'm sorry if I mispronounced your name. I've got a question from Chandan. How do you rank results from different content types like books, courses, and videos?
Yeah, great question. That's something I touched on a little bit, but that's really ultimately our biggest challenge in our search engine. We just keep adding more and more different content types. And you can imagine discoverability for a book is way different than discoverability for a live online training, right? And so right now what we do and what we've always done is just mash them all together, and they all get the same index. We try to normalize their fields as much as possible. But you can imagine like a live online training might have a field on like when that training will occur. And that's just a field that a book wouldn't have, right? And so as much as we try to normalize those fields, they're still going to be different. And that's something that's going to be a next big challenge for us, is really improving discovery for each individual content type, and not just trying to mash them all together in the same search engine. They all get the same relevance algorithm.
Cool. There's a question from Andrew, but I think you covered this pretty extensively about using search logs to optimize searches, and how you use that data. You talked about just looking at the queries that you get, the popular queries that you get, and also using it for CTR and MRR. Are you doing anything else there?
No, that's about it. I will say that we did, initially our query groups were mostly based off of our most popular different types of query groups. And so, there's those tail queries where they don't look any like our head queries. They're queries like content search queries, or maybe even like actual questions, right? And we weren't taking a look at those whenever we first pushed out our initial improvements, right? We were trying to, kind of like the 80-20 rule. We're trying to hit those head queries first. But now we're circling back to those tail query groups and establishing a lot more query groups. So we started out with like 5 query groups, and now we have 10 query groups, and we're just going to keep doing that. Keep looking at our search logs and trying to build that query group list.
Cool. Question from again, apologies if I mispronounce names. Rohit, have you used LTR at all? Have you looked into using learning to rank?
Yeah, great question. So yeah, learning to rank is a really cool tool. I've looked into that a good bit. I actually took a training from Open Source Connections on learning to rank. And it's really cool. It seems like it'll be really useful for us in terms of re-ranking the order of the results. We're not implementing it yet. We're not quite there yet. And for a myriad of reasons. One, we don't have a good like judgment data or click modeling system. We don't have good data set for, building the LTR models or testing them, right? And then 2, also, we're still in a stage where we're trying to demystify search for everyone else in the company. For so many years, we didn't have anyone that knew search relevance or knew search engineering. And so now we're just trying to get to a point to like explain how our relevance algorithm works and demystify that. And so you can imagine with LTR, like that just adds a whole huge level of mystery to it. And we're not quite at the level where we can add something big like that we just can't explain whenever someone asks how the relevance algorithm works.
Yeah, it's good to hear that you know that you're not ready and you're not trying. We've seen a lot of cases in the other direction where people are like, yeah, we got to do LTR, and they're clearly not ready with the data, but they try anyway. Good to see you're taking your time there. Another question from Peter Dixon Moses. I see recency and popularity as relevance features. Do you have a specific strategy for ensuring new content has an opportunity to be discovered?
Yeah, so that ultimately is where our recency boost comes into play. At the time, like before we added popularity boost, mostly like it was new content that was constantly being shown, and that was good. Like it helped improve discovery of new content. Like if you would issue a search, like a star search, like not actually give a search query, what you would see is basically all of our content sorted by their recency, like when they came out, when they were published. And so, that recency boost does a pretty good job at establishing, showing our users like content that just came out. Now, since we've added the popularity boost, balancing the two has been pretty fun, right? Like at first we added popularity boost, and then people were saying, oh, why can't we see this, thing that just came out, right? Well, it's because, our popular content from 5 years ago is dominating it. And so we've been trying to adjust those two metrics and make sure they don't compete with each other. But it is an ongoing challenge.
Yeah, I'm gonna jump in and ask a follow-up question to that. So judgments can get stale, right? So you have to put in a lot of effort to do judgments. So as new content comes in, how are you maintaining your judgment list?
Yeah, so that's a great question. Maintaining judgment lists, really, like we want to be constantly adding more judgments. And this gets back to the idea that it's so crucial for us to make capturing judgments as easy as possible. And that's why we added it directly on the search page. So even if, our search team is busy doing something else and we can't be, adding judgment data or updating judgment data, we can open it up to other people inside the company. And so it's not just the search team that's building that data set. We have a lot of other minds working on that. But that is an issue, like that is something that we have to be cognizant of. And we are going to have to go back and, update our judgment ratings and keep them fresh. One example we saw recently was, I didn't talk about this much, but our search results have playlists, and playlists are essentially, user generated content. Like a user can go create a playlist, add their favorite books to this playlist, and then make it public. And making it public means that it goes in our search index, it goes in our search engine. But you can imagine like that user can go back and 6 months later update the contents within that playlist, right? So at that point when they do that, our judgment rating that we recorded for that playlist given a query may be pretty stale and not be accurate anymore.
All right, question and some compliments from Richard Gilmain. Great talk, thank you, Anthony. I like that you distinguish among different types of queries, like the title, the author, the topic, the mixed keywords, etc. Do you attempt to explicitly identify what kind of query the user is performing at query time and run search differently? Or do you always search over the same fields and attempt to combine their scores somehow?
Yeah, that's a great question. So right now we are doing the latter. And this really gets back to that question earlier about, do we apply different search relevance algorithm for the different content types? We don't right now. Like we're not doing any kind of query intent detection. We're not, using different relevance algorithm for different content types or queries. But that is like the next big step for us, right? If the user types in a query that is obviously looking for live online trainings, well, if we were able to detect that in our query, then we can, maybe add some auto filtering, or at least, kick in the live online training relevance algorithm, for instance, and, provide a much better discoverability, because ultimately, discovery across the different content types, as I said, is drastically different. So we don't do that today, but that is a huge thing that we want to do next. One thing I didn't touch on, but is still a serious issue in the search engine, is we have a really high recall. Whenever a search user issues a query, they usually get like a lot of results, and we're not doing any kind of like auto filtering or cutting down on that high recall to make it more precise. And so really being able to, if we were able to have that query intent, we would be able to do things like auto filter and cut down that recall and make our results more precise.
All right. Maya, I see your question, but I want to get, you already asked one. I'm going to get to some other folks. Kevin Waters asks, did you take advantage of the Elevate component in Solar as a last-ditch effort to make sure you fix specific relevancy issues?
Yeah, great question. So we did not. Elevate is a great tool where you can, really just elevate content like manually. Like you say, I want to elevate this specific result, right? We didn't do that at all, and that would have been a pretty easy thing for us to do, like elevate the clean code book series. But we were really trying to look at. We knew that there wasn't any specific query or specific content type that we were asked to elevate. It was more so just on a more broad scale of, hey, like the search engine just sucks, like we need to improve it. So we didn't spend too much time worrying about Elevate. Instead, we were trying to just like improve the entire like search query group.
All right, question from Carlos Fonchiato. Some books reference other topics. Have you thought about using a knowledge graph?
Great question. Yeah, most of these questions are, it's like, yeah, things that we don't do today, but we know it's like a good next step for us. So yeah, we don't have a knowledge graph today. Our topic service, the service that automatically tags results with topics, it could potentially be built into a knowledge graph or evolve into a knowledge graph. We've talked about that. We've also talked about this idea of being able to have multiple topic tagging, right? So a result like relevant search, for instance, it talks about both Solar and Elasticsearch. So could have the search topic, but you can see it could also be tagged with the search and the Solar and Elasticsearch topics as well. We don't do that today, but we see that as an area that could really boost our search results, because as I've been really showing, like topic queries and having that level of enrichment is by far most popular use case.
Right. Question from Vincent Brand. Do you explain the relevance ranking presented to your end users? Since you have high recall, do you encourage them to use facets or drill down search? And is it used?
Yeah, great question. So we don't really give much relevance feedback to our users. We recently, whenever we added, querying on the topic names, we added the actual topic label to results. Before that, like we wouldn't add that. So you would see the results, but you didn't know what topic was tagged to that result set. We've added little things like that, little feedback like that, right? But we're not showing how popular that result is, or any kind of like actual like relevance matching feedback to our users. We want our users to be using our filters, right? Like recall is such a big issue for us. We don't see a ton of use for them. We see a lot of use in our format filters. That is by far our most popular filter usage. And so that really points back to that fact that each format, each content type has its own discoverability needs. And so users seem to get that. They know that like, I should search within books instead of just searching all, because clearly I get a different experience. But we want to encourage more filtering, but we're not quite there yet.
Cool. Question from Danielle Volpe. When building the judgment lists, if your engine has high recall, do you have to put judgments on all the results, or are you just doing the first N?
Yeah, great question. So we weren't, whenever we were building judgment lists, we weren't noting like how many results were coming back. We were just building judgment data off of the first 30 results. Really what we were driving towards was, improving that first page of result sets and, first couple of pages. Really, we didn't care as much about the relevancy on page 5, because ideally the users never even get to that point, right? And there's a lot of edge cases there. Like I talk about browsing behaviors and queries, but we were really just targeting those, most popular use cases. And we wanted to get users to just stay on that first page and find what they're looking for there.
All right. Coming back to Maya's question, second question, she asks, you were talking about LTR. She asks, is there a reason your judgment lists can't be used for training small or simple LTR models?
Yeah, great question. So there is no reason. Like that's exactly, whenever we do get to the point of building LTR, that's exactly what we would do. But at the time, our first iteration of judgment data, what we were doing was building it as a very small volume of judgment data, right? 30 results, maximum of like 40 queries. And also that judgment data wasn't changing over time. So we were recording in Google Sheets, but it wasn't being stored anywhere like a database that we can reuse. And so that's at the level that we're at now. Like now we can record judgment data that goes off and is being stored in a database. And now that we have that volume and that persistence, now we can actually use that for something like LTR. And so, a lot of these questions are like, ideas of like for a future, like, improving our search engine in the future. And that's exactly what I mentioned when I talk about like developing a lasting relevance process, right? Like our initial relevance testing is far from ideal. And even our improvements are super basic, super fundamental, nothing surprising to folks here. But, we have this process in place so that now we can start to, push out these improvements, get stakeholder buy-in, and then use that buy-in to spend 6 months to, establish learning to rank and, improve our search results that way.
Cool. Last question from John Kane. He got one into the last minute. Have you considered UI or UX improvements in coordination with a backend search, such as a search halo around the search box? And then he just added, FYI, search halo is the color-based theme around the search box, starting with red going to green as they enter more search terms.
Oh, nice. Yeah, I appreciate that clarification. No, like we haven't actually thought about too much about UX feedback like the search halo. We talked about like relevance feedback. We've thought about things like, adding the results topic tag, or, showing some way to say that, this is a popular content. But we haven't thought too much about like UX feedback for the actual query, like as they're entering queries, or, giving more feedback like while they're typing it in. I will say, I didn't talk about this too much, but we have search suggestions. And so, as a user starts typing in like a topic or a title, they can see that topic or title show up in that search suggestion dropdown. So we give that feedback, but that's more so like a feature than like UX feedback, right?
Okay. I'm going to keep going with questions if you've got time. Carlos Sponchiato asks another question. Are you considering using Cupid?
Yeah, great question. Yeah. So there was a point in time where we were saying, okay, we want to build out more relevance tools, and we were looking at all the different tooling out there, Cupid, ranking evaluator, that kind of thing. We were this close, like we were familiar with Cupid and what it took to stand up, and we were really close to using that. Why we didn't were for two main reasons. One, our search service, that Django service, it adds a lot of additional, parameters and business logic that isn't built into our Solr. And so all these tools that, just point to the Solr cluster, they don't quite paint the full picture, right? Like they're not, the results that you get back from Solr might not be the same as the results that you get back from our search service, right? And so that, encapsulating that difference is really important. And then the second reason is really just trying to demystify these tools and open up to other people outside our team if needed. So Cupid's a really easy tool to use. That's not the best example, but it's much more intuitive and easier for other people outside our search team to just use our search page and make tweaks and record judgment data directly on our search page than to have them go off and learn this brand new tool.
Yeah, good point. Another question from Richard Gilman. How do you know what your topics are, for example, Python and JavaScript, and how do you map your content to those topics?
Yeah, so we have a service that's dedicated to just that. It uses machine learning to say, given a title, the content or the description of the topic, or description of that result, tag a topic onto it. It only tags one topic onto it. It does a pretty decent job. It's not perfect, obviously, but we have a service dedicated to that, and constantly improving that is an ongoing effort. You can imagine one thing that we saw was, we're adding in topic names into our relevance algorithm and adding a pretty sizable boost to it. Immediately what that uncovered was a lot of incorrect topic tagging. So as we were building those judgment lists and testing out those results, I found a lot of results that were incorrectly tagged. And so, that is an issue with, adding something like that isn't a for sure bet into your relevance algorithm. You want to be careful about just how much you're boosting that. And, you can only boost it so much as, how much confidence you have in that, that topic tagging.
Cool. Question from, and again, if I mispronounce names, I apologize. Leonardo Weinstock. Great talk. When you mentioned you didn't use much of the MRR metric, you said it was because users used to go through more than one page while they search. When calculating MRR, do you consider all clicks in a session or only the first one? If you consider only the first one for a session, it should measure how fast the user finds the items they didn't use. Not sure the last sentence was a question, but maybe talk about your MRR calculation a little bit more.
Sure, yeah. So for the MRR calculation, we were looking at all the clicks, right? So it might be, kind of browsing behavior. So they click on the first result, then, also go to the second page and click on a couple results there, and go to the third page and click on a couple results there. So we were capturing all of those clicks in our click data. And it's really just about how our click data is set up. Like we didn't want to exclude like other clicks and only focus on that first click. And so we weren't able to, for MRR only look at, the very first click. But that is a really good idea to, at least work around part of that browsing issue. And so you can imagine, like, even if the user is browsing, you'd want them to at least click on something on the first page higher up before they click on other things.
All right. We are out of questions, but what I'm going to do is, Anthony, do you mind if I grab the share from you?
Not at all. Let me go ahead and stop sharing here.
Now I gotta find Zoom, of course. Zoom, where are you? Oh, that's the wrong slide. Anthony, thanks a lot. I really appreciate it. That was an awesome talk. Thanks again for coming.
Yeah, thank you.
You're on Relevance Slack, right? So if people have follow-up questions, they can grab you on Slack.
Yeah, I'm there. Please feel free to reach out to me and ask more questions.
Cool. We're also going to upload this talk to YouTube later today. So we'll post a note on Slack for those who couldn't come. And if you join late, you'll be able to watch the beginning. So I'll drop a note when that's uploaded. Just a note, so we've got some upcoming talks. We've got Adam Waltz from Box coming next week. He's going to be talking about solar beyond the core. And then in July, we've got Dilip and Manohar from Target. They're going to be talking about context-sensitive autocomplete suggestions. And they've got a pretty interesting talk. They're going to use some deep learning stuff for their autocomplete that they're going to talk about what they did. We've also got some training coming up, and you can see a list of all the recordings and all the slides from all the talks if you go to Haystack.conf. And that's all. We'll see you next time. Thanks again. Bye-bye.
Thank you, everyone.